Hello, it's the next part of robot dog development. This is OpenDog, which is an ongoing project, and it's a very rigid robot which has rigid joints driven by ball screws. So I was having some trouble getting that to walk in a more dynamic fashion, so I decided to make this test rig, which was sort of like the Jumpy Dog 2, and that dog has back-drivable joints, which the motors are held in position with some holding currents, but they're back-drivable, and that makes a virtual spring. And I tried dampening that spring out with a PID controller that makes the actual joint position drive the joint to that position. So when you push it, it basically tries to drive a little bit to that position, and that makes them compliant. So that made the dog look quite dynamic, and that's the bit of footage you saw at the beginning with me hitting with a broom. But you've noticed it was hung up on bungees, and that's because the legs are just about strong enough to hold it up when it's standing there, but when you take one off the ground, the other legs are no longer strong enough due to the gear ratio of the gearbox and the weight of all this metal in there. So I was going to go back to OpenDog and use the things I learned from this to try and simulate springs with the rigid actuators with foot pressure sensors, but actually I've got quite hooked on doing dogs this way, so I'm going to go on and build a second test dog, which we're going to start in this video, and that's going to be much lighter with a better gear ratio and more 3D printed plastic, so there's less metal, and hopefully its legs can hold it up by itself. So the key differences from last time are we've got these big gears in the leg now, which give us roughly a 4:1 ratio instead of the 2:1 ratio that we had there before. And again, that gear runs onto the motor with a toothed pulley that needs fitting on there, which is the same ratio, so we should get half the speed, twice as much power, and all of the yellow and grey parts are 3D printed plastic this time, so it should be much lighter than those aluminium plates and aluminium extrusions for all of the legs. There is one aluminium plate in each of these gearboxes that holds the motor there, which we'll need because the motors get fairly hot because we're driving them pretty hard, and we've got an aluminium chassis at the top to hold it rigid. Now we'll talk about it later, but the feet also can have pressure sensors in, and these are going to be hybrid prints with some flexible material encapsulated in rubber material. So that's going to take a bit of experimentation, and that's going to come up in a future video. That'll allow me to see when the feet are on the ground and alter that compliance, so it should be able to hold itself up much better. Before I could assemble the new legs, I took the old legs to pieces to get various bits of hardware, including the motors, the pulleys, the encoders, the belts, and various other nuts and bolts, which I've tried to reuse in the new design. So I've made my 4 legs. I'm really happy with the way the gears mesh because they seem to be working really well, and I have only just sort of placed those once in CAD, looking at the CAD for the gears, and they seem to mesh really well. The belts are really tight that we've got in there as well, so that's all looking good. So now we need to put these legs on a frame and try and put some electronics in and try and get the thing powered up. So here it is all mounted up on its frame. It's pretty big actually, it's bigger than I expected it to be, and it's still going to go taller because we've still got those feet to put on there in a future video. But it's a pretty robust frame, and of course it's much wider because it's actually gripping each leg either side. Each leg is currently mounted on a pivot point, which means we could tip it one way or the other by taking 2 blocks off and putting an actuator that actually tips the leg. For now it's just going to be impact testing the ground pretty much, but we could push it along in the future if it works out really well. So I fitted the electronics from the old dog and just plugged the motors and encoders back in. So it's pretty hacky on a bit of breadboard, but as before we've got a Teensy 3.6 and 2 ODrive 3.6s, which are the 56 volt version. They're only running on 24 volts each one, but that seems to be enough power and speed for now. With those motors we could go to 36 volts. For now, as I say, I've got 2 24 volt packs, which are 6 cell LiPos, and we've got the big emergency stop switch, which cuts off the ODrives by pulling the reset pin low. So I've powered the legs up, now let's take it off the stand and see if it holds its weight. They feel pretty tough, so with the lightness and the extra power we should be okay. Right, so yeah, we still got that natural spring in the legs, but yeah, seems to hold its weight all right. Let's go and pump the legs and see what happens now. So I'm pretty happy with that. It's at least as good as the last version, and also this one holds its own weight up, which is pretty good. Now it looks like it's tipping forward quite a lot of the time and getting stuck in a rut, and that's probably because the balancing point of the feet is quite far back because of the way it's structured, but of course we've still got those feet to put on that's going to put that balancing point forward on all of them, which will have the tendency to tip it back more. So hopefully it'll balance up, otherwise we'll just move the batteries around till it's roughly balanced. And then the plan is pretty much what I said last time, is to have those foot sensors, so the foot stops when it hits the ground, or does something, perhaps it becomes a softer touch or something like that, which means that when it pushes that foot on the ground, it doesn't push the whole dog back, and that's what the problem is with OpenDog, and that's why I'm doing this investigation. So the next thing is going to be putting the feet on, putting the foot sensors in, and basically trying to balance the compliancy of each leg based on an inertial measurement unit and the foot sensors to try and keep it level all the time. And at that point we should be able to stick obstacles under its feet as well and find that it complies with those and it always stays level. So sorry the video's a bit shorter this week. Obviously there was quite a lot of 3D printing and assembly to do to build this whole dog in one video, and we've still got I think at least another 2 videos before we get it up and running with all the things I just said. So don't forget to subscribe for more updates on this project and all the other projects. And if you'd like to help support the channel, I have Patreon and YouTube channel memberships, so check out those links in the description below. Alright, that's all for now.